In this lecture, we're going to talk in more detail about neural networks, and we're going to focus on image recognition. And we were going to bring back this idea of the perceptron that we talked in previous lectures. And now we're going to think about the perceptron instead of one perceptron. We're going to talk about what happens when we have hundreds and millions of perceptrons. Yeah. And so in the same way that we were thinking about our brain that have millions of neurons working together and interconnecting, yeah, with so many connections, now we're going to have a, a machine learning that is inspired on that, yeah. So all this interconnection of perceptron working together, and they're able to do something that in the past it was impossible, that is doing image recognition. And we will talk a little bit about history, how this field developed really fast, yeah. And we're going to talk about the hidden layers of these neural networks that are just pure and beautiful math that allow neural network to become one of the most dominant learning technologies used now in 2025. And we're going to talk a little bit more about deep learning, and I hope that you enjoy a lot this class a lot. This is based on the Crash Course AI. If you want to see this in more detail, you can watch it there. So to summarize, in this class, at the end, I hope that you remember that we can do much more thing when instead of having one perceptron, we have millions, yeah? And this is what we call a neural network, when we have all these perceptrons working together. And as I said before, this is one of the most dominant machine learning technologies used today. Why? Because it allows us to do much better jobs that they were considered possibly impossible in the past, like image recognition. So I'm going to talk about this example of differentiating images like dogs. Yeah, that right now it looked like something very simple, but for computer that was before AI, it was very complicated. And the key, and I want that you pay a lot of attention when we talk about hidden layers, because that will be very important for neural network and later for another type of machine learning that is deep learning. And remember, math will be very important in these hidden layers. Okay, so let's start. Okay, so here you can see a picture of a dog, and here you have a picture of a cat. And I'm sure that if you go to internet, you will find millions of pictures of dogs and cats. We love our pets. And by the way, I have two beautiful cats. And why it was so difficult for a computer, yeah, to recognize that this was a dog and a cat, because um, although we see an image, what a computer will see is one and zeros, yeah, combination of zeros and one and zeros and one. So for a computer to recognize a dog or a cat or any other image, it was very complicated. Yeah. So this was something that long time ago it was almost impossible. So AI, before AI, this real world image recognition was very difficult. And I'm giving you just an example of a dog or a cat, but for example, if you have a social network and you are tagging somebody, now thanks to neural network, they know exactly where are the eyes, yeah, and the face, the lips, and in that way they recognize that there is a face there, yeah, and in that way you can tag somebody using social network. So this is something that you are using all the time, but maybe you don't know. And I'm going to show you many examples of how we use artificial intelligence and in particular image recognition right now. So something that computers are very good and they have been doing since a long time ago is to say if those two pictures are very similar or not. Yeah. So is this one similar to this one? So we see it and we say, yes, kind of, they look kind of the same. The computer can tell you if it's exactly the same or not. How? Because they are just matching zeros and one, yeah, and they do it very fast, much faster than us, and they will be able to say if it's exactly the same combination sequence of zeros and one. So remember, for computers, it's very easy to these literal comparisons, yeah, because they are matching zeros and one, and and this allows them to match in the pixels that you see there. So this is something that computers are very good to do, and they have been doing for a long time before the appearance of AI. So what is the problem that a computer had before AI with image recognition? So it was, for example, with picture like this one, that you have different type of dogs. So it will be very difficult for them to say that all of them are dogs, or even to compare and say like, this is the same dogs, this is the same type of dog, yeah, even the same dog, but in different poses, yeah. For matching, to get that information from a combination of zeros and ones, it was practically impossible in the past. And so remember, so before AI, when you had a picture like this, to say that these were different dogs or they were the same dog, it was very difficult to do, yeah. And there was no hope in telling that there was different dogs or cats or cars or plane. That was in the past impossible before AI. So in this slide, I'm going to give you a very general introduction of what is a neural network. And to do that, I need that you remember what is a perceptron. So if you haven't watched what is a perceptron, please go on and review that in the previous lecture. And here I show you the classical algorithm of a perceptron. Yeah, and as you can see, it has different components. So if you remember, it has inputs, it have weights, it have the addition of the values here. It has an activation. Yeah, if it goes over a threshold, it will give you an output. And the output is, for example, if we have an image here, and I'm giving my best, let's suppose that this is a triangle, and it will tell you this is a triangle at the end, or this is not a triangle. Of course, the first thing that you need to do is train it. So you give it hundreds and hundreds of pictures of triangles, yeah, and the perceptron is going to learn the correct combination of numbers, yeah, all the pixels, how they should be organized to say if this is a triangle or not. Okay, so just as a reminder, I just tell you, I give a small recap of what is supervised learning. Tell you that you need to train first the algorithm, yeah, and that in this case the perceptron has different components. And I gave you the example of the triangle. If you go and watch the video lecture, I give you the example of how to get, for example, good grades, how to get A classes, yeah. So what we do is to have different parameters. So here you can check which one are the parameters that that um that you think that are more useful, yeah. So you think about, okay, how when I got A's or A pluses in the test. So I said I went to class, I did the assignments, did I read the textbook, and you can see which one are the 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 parameters that work better for you. So some of you say like, I think if I read the entire textbook, yeah, all the chapters in a lot of detail, is much better than going to lecture. I can go and watch the video lectures and see the key components, but actually the textbook for me work better. Yeah, so the weight, yeah, it will be higher. Yeah, you will give it a higher weight to that parameter. For one of you say like, taking the quizzes is very important for me because that give me practice, and it could be different for different people, and this is how you adjust the weights. And again, this is just an example. I invite you to go and give it a look to that. Now I'm going to tell you what is the big change that we have. So when you take not one perceptron but many perceptrons, as we have been talking, this is this change, yeah, connecting all these perceptrons together. That is what we call a neural network. It allows you to and do much more complicated things. So, and just from a very general perspective, here, look, here you have an input that is the image, yeah. Then you have these hidden layers that I will talk in a second in more detail. And here you have an output layer. So is this a cat or is not a cat? Is this a dog? It's not a dog. Is a cow? It's not a cow, yeah. Or you can have the tree as in this neural network. That depending on the architecture, you can do more complex things like differentiate between these three animals. And how you do that, Yeah, so we not only have, again, inputs, weights, math there, and outputs on, we have also these hidden layers. Yeah, and we can have different amount of hidden layers. But if you see here, what we are actually doing, if you see, the ears of the cat look like a triangle. Yeah, so this is what the hidden layers will be doing. The eyes of the cats will look like a circle. So maybe some of those layers, what they are detecting is some of these parameters. Uh, and so this is why you can have multiple neurons, yeah, doing these kind of things. Yeah, so when you have more hidden layers, you can start getting more complexity here. So to summarize, I will give you a recap of what was supervised learning and perceptrons. And I tell you that what is a neural network is a connection, is connecting multiple perceptrons, and this will create a neural network that it will allow to answer more complex questions, like recognizing if not this is a triangle or not, but recognizing of an image of a cat that have many more geometrical shape with different colors. Yeah, that in that case it will be much more complex. Okay, so now let's move to the next question. That is, but why we need to do neural why we need neural networks to do these kind of things. And so why do you think that we need neural network? So this again, it was inspired, if you remember, the perceptron were inspired of the neurons, and but with a single neuron you can do some things, but actually the our brains that are the collection of many neurons, uh, they can do much more complex things, and they are formed by billions of neurons with trillions of connections. So it allows you to do much more complex things. So the same thing happened here when you add so many perceptrons. And in the case of image recognition, they are excellent to do that. I'm going to show you in the following slide the history of how this happened. Yeah, this didn't happen. This happened really fast, but it has a recent history in which things exploded in terms of the progress that it was allowed. And again, here the key is that you have three key components that I will keep repeating all the time. You have an input, like in the perceptron. You have an output. These are mathematical values. And here you will have hidden layers. And you can have here, you only have hidden layers, one hidden layer, but they could be many hidden layers. And we will talk about that, the different architectures in the following slides. So remember, here the key is that these hidden layers is one of the aspects that make them more powerful to be able to do complex things like recognizing an image. So before moving to the history, I remind you this architecture of the neural network uh, was able to solve many problems. Yeah, I remind you that as a computer used to struggle recognizing objects, and I show you the pictures of the dogs. Yeah, and why? Because the previous method, the traditional method, it was just comparing pixels. So the computers were excellent at comparing, for example, this bitmap with the other bitmap, and they were able to recognize that they were dissimilar and tell you these were the pixels that the difference is here, but this is not image recognition. This was an ineffective method. So this traditional method that relied on pixel matching were very good for comparison, but they were not good or ineffective for image recognition. And this was changed due to a professor that did a very interesting competition that it helped to develop this field. Okay, so now we're going to talk a little bit of the history here, and I'm going to play a video where this professor the professor Fei Fei Li, and the researcher create this ImageNet. And she will say something that is very interesting. At this point in history, even the smartest computer, yeah, even a computer that he was able to beat the best chess player of the world, it was blind. Yeah, they were not, as we said, they were not able to see, to detect images. So to solve that problem, and this is something that had happened multiple times in science, we use two tools. One that is crowdsourcing, yeah, so we collaborate, we all work together, and then we compete to speed up the progress. So let me show what they did. So here, and she will describe a little bit later in the video, a small TED Talk. She has two TED Talk, one um, around 9 years ago, 10 years ago, when the field started developing really fast, and now one few months ago describing more about the future of AI after this huge discovery. So what they did is to have, if you see all these images, so the computers were blind, they were not able to detect images. So what they did, we can have two options, that everybody start downloading images and biasing their own results by, I don't know, picking easy images and said, oh, we did very well. Or other people say like big difficult images and said like, uh, okay, our images, this is not working very well, but it was working better than the other ones. Instead of doing that and spending so much time, what they did is create a huge public data set. So everybody started working in that data set. And now that we have all the data set, the scientists, instead of working on creating the data set, they were able to test the algorithm, and they were working on that. And so when I was thinking about how many images, I thought that there would be maybe hundreds, maybe thousand, but actually there were millions of pictures. And so they were 3.2 millions, and there were 5,000 categories. So pictures of cat, pictures of dog, pictures of plane, pictures of humans. Yeah, so they create all these categories, and through crowdsourcing, they were able to efficiently label them. So instead of one person label them, that it will take forever, it was many people doing a little bit of work. So many people doing a little bit of work, they were able to do a lot of things to label this, and then they were able to meet once a year to talk to see the results. And I'm going to play the video, a part of the TED talk. And if you want, you can of her, and if you want, uh, you can see it all the TED talk. I just want to show you a little bit of the introduction that is very interesting. So now I'm going to talk about this rise of neural networks. So I told you, and you already watched, that there was a competition here using this figure and the figure of AlexNet. Hopefully, I can tell you the story. So here you see on the top 5 errors. Yeah, when they started the competition, trying to recognize images, and they start showing who was the winner, and how the percentage of mistakes. And if you see here, there was a huge reduction, and that reduction was to neural networks. Yeah, and if you see, slowly it start getting smaller and smaller. And here, look, 5% of mistakes of humans, and so now we are lower than the mistakes that a human can do, that now computers can see and can see better than us. And okay, you may be thinking, okay, this is very interesting when we think about Facebook that can tag pictures, or Instagram, but it's actually not very important for real purposes. But actually, this was very useful, for example, for detecting cancers. So now computers can detect cancer much better than the technicians that have worked for years on that, and they will continue improving on that. And we will also show you that protein folding and other fields have developed, also answering very specific and difficult questions, have been also solved using neural network with this type of technology that, as we said, is very important. So here we have AlexNet, that is the one that revolutionized everything. So here, if you remember, we have an input that we have talked in the beginning, and an output telling us this is a dog, this is a cat, this is something else. And here, the main difference that they found comparing with other groups is that this AlexNet was the hidden layer that has a lot of hidden layers that this create it was a game changer. Okay, so I just told you that there was an annual competition and that this competition started 2010. Yeah, so these were the winners and they start going from 20%, like one third of the computers were the computers were not able to recognize it properly. There were mistakes, but when they start contributing to solve the problems, 2 years later, this in 2012, the AlexNet that it was created by this person revolutionized image recognition and how the key innovation were two more hidden layers and faster computers. Yeah, so instead of having again one perceptron, one neuron, you have many more neurons, and now you have even many more because you have many hidden layers and you have very particular architectures. And for that, you need for more hidden layers, you will need to have faster computation. If not, this will take forever. Okay, so now let's move into the architecture of the networks, and so we understand in more detail what are neural networks. In this section, we're going to talk about how neural networks work, and to that, we're going to start doing that by understanding a basic architecture. So there are many architectures. Here we're going to just show a multi-layer perceptron. Here you see an input layer. Here in blue. Here you see the hidden layers, and they could be several layers, like in the AlexNet that we talked before. And here you see the out layer. Okay, so remember, all neural networks are made of three main components: input layer, output layer, and any number of hidden layers. In this case, we only have one. But there could be, and we will talk more in the following slides and during the course, there are many different arrangements, and the arrangement will depend on the needs of each neural network, which one will work better to answer the question that you have. And in the case of this example, we're just going to go for the classic multi-layer perceptron as an example. So let's talk in more detail about the input. The input layer is where the neural network, yeah, receive the data, and this data should be represented as numbers. So you can have the image of a cat and you can see pixel brightness. You can have sounds, yeah, and that sound it could be represented as a number, yeah, as a number in the amplitude or the frequency of sound, yeah. So you can turn everything into a number. If you are we talked last time about the perfect donut. So you can have uh, how much sugar should be in a donut. So you can represent that in grams of sugar. Yeah. So the important is that here everything should be represented with numbers. Remember, each input of represent a single feature, and a feature is a characteristic of the data. So I already told you three examples. I told you the example of the pixel brightness in, for example, in the image of a cat or any image that you need to recognize, a gram of sugar in a donut, or the amplitude of a sound wave, for example, in music. But independent of what it is, anything should be converted into a number to be able to be analyzed in a neural network. So let me show you more examples. Okay, so here again, you can see the waves. So this is, it could be sound, it could be music, it could be the sound of a whale. That now there is a lot of work trying to understand how whales communicate, how animals communicate, and what we're doing is having turning waves of sounds into numbers. So you can use the amplitude or the frequency, yeah, how often you hear those sounds, and turn that into a number to feed it into a neural network. Yeah, so you will add that into an input, and you will later give a weight, a bias, and an output. Okay, so what I just told you is that sounds can be represented as amplitude of the sound wave, and that can be turned into a number, and this can be a future that can be represented as a number in a neural network, and in that way it can be fed into a neural network. In addition to that, for example, every time that you text or you use PowerPoint or Microsoft Word or any of those software, you can have a prediction. Yeah. So you are texting, for example, something about your cat. So the first word is cat, second word set, third on, and you will receive a suggestion. Yeah. And the neural network allow you to predict what will be the next word in a sequence. And for example, if you have been texting a lot, and so the network is learning and learning, yeah, you're training every time that you text, it can say you predict that it could be the word math. Why a math? Because you have already tell them that you have a math, and they can generally sit there. So this is the most likely word that it will be appear there. Here I don't show you the math, but each one of those words it will turn into a number. And later, when we talk about NLPs, very important, NLP, natural language processing, we will talk about ChatGPT, all those things, how they turn this word into numbers, and we'll talk about transformers and all the things. But right now, what I want that you remember is that in the way that we already taught with image recognition, and I'm going to show you an example later, how computers can see. Another very important part is not only how they can see, but how they can also talk and communicate to you and understand what they are saying. And language is very important, so NLPs are very important. So we will have an entire class that talk about how computers are able not only to see but to communicate and turn these words into numbers, and then be able to give you answers, to generate answers for you. Okay, so in the same way that we do it with sound, we can also do it with words, and you can do it predicting the sequence of words. That is what we're always doing with your text when you're texting and you receive a suggestion. Or they can also use how many times each word appear in a text, and there are many sophisticated ways in which we can use neural networks to understand a text, and we will talk about more about this topic later. Okay, now I'm going to go again into the image, and I'm going to show you in a little bit more detail again how the input go into an image. So now we're going to teach a computer how to see, and the first thing, similar to the previous, to input the data, we are going to have to turn this picture into numbers. So the feature that we are going to use here, for example, is the brightness of the pixels. So here, some computers use scale that is 0 to 255. So for example, if I use ImageJ, I will see this scale, and the darker region of this image of a dog, the background, it could be close to 0, while the area close to the eyes, you see, is wider. So that area will be, I don't know, close to 200. Yeah, and you can find that each one of the pixels there will have a different number depending on the pixel brightness. So what I told you there is when we are trying to teach a computer how to see, the computer is going to see this. Not going to see an image, it's going to see number. So you are going to give a number to each one of the pixels. In this case, if it's darker, it will be closer to 0, depending on the scale that I give you. Yeah, based on the scale that I give you. If it's wider, it could have a higher number. And the question that we have is what happens when you have images that have color? So we can see in black and white, but we can teach a computer also how to see in colors. And to see in colors, the key is to have a computer with a higher computer power. And you have heard about this story before. Maybe if you know about ImageJ or you use Photoshop, you have heard about this R, B, and G. So red, blue, and green. And the idea is when you can produce any different color by changing the combination of these three colors. So you turn that into a number. You say like a lot of red will be a number, and a little bit of blue could be a different number, and you come and you can put also green, and you can have different numbers, and these will turn into any of this when you combine them, and in that way you can not only have you can have a number that it will give you also colors. Okay, so you can not only see black and white, but you can see using colors by turning this scale red, blue, and green that use computer screens into numbers. So I told you that we can see in grayscales using computers, using the brightness of the pixels, but when we need to see a color image, you can turn this pixel in three numbers, depending on the amount of red, green, and blue, which can be combined, which can make any color in your computer screen. Okay, I know that this doesn't explain everything. I just want to give you a little brush of all this information. Okay, so just to summarize this area, I was talking about how neural networks work. I told you that there are three main components, and the first component is the input, and in the inputs you need to add convert any feature into a number, and I show you that you can do that with sounds, with images, with words, and with anything, and in that way the computer can give you an answer. If you don't turn anything into a number, yeah, the neural network is not going to work. Now let's move to the next stage, that is the second component, that is the key here for the neural network, that is the hidden layers. Okay, so now we move to the next layer, that is the hidden layer. So we add all our data, all these features. It could be sounds, it could be words, yeah, it could be brightness of pixel. We turn that into numbers, and this will go into the hidden layer. And how it goes, so in the simple perceptron, you will have weights, you will have a bias, and in this case, in a simple way, they will be added. Here you have a much more complex architecture, although this is only one, you are combining and adding different values. Okay, so the idea is that when you combine those values, yeah, mathematically, the idea is that the neural network will try to detect any pattern that are in this data of the input, in the sounds, in the waves, in all those things. Okay, so I just told you that the next step is the next layer is called the hidden layers. Yeah, and the in the next in the this hidden layer, the neurons mathematically combine all this data from the input, and what they are trying to do, the main goal is to measure whether the input data has certain components. And here the problem that we have is that we don't know exactly what the hidden layer is doing. Yeah, so when we make these networks, uh, later you can go and many times to make the best hidden layers, to make the best algorithm, you go and try to see what actually the neural network is doing, but in theory we don't know exactly what it's doing. So let me show you some examples of what we think. That's in some cases, some people that have tried to see what the hidden layers are doing, what they can be doing, but again, we don't know exactly many times what they are doing. Okay, so now we're going to talk more about these hidden layers. Here you can see three diagrams. Here, the one that we have the input layer that we already talked, and here you see a black box that it will be the hidden layers, and the output layer that is that. So the two layers, the beginning and the end, are very clear. The data that we're putting and the answer. However, the hidden layers is not completely understood. And I'm going to show you, we are not completely sure what we are doing all the time with all these neural networks. Yeah, I'm going to show you that to some degree we can get some of the guess what the algorithms are doing. Yeah, and in that way, when you know more about that, you're able to improve the neural network even more. But the deeper that the more hidden layer that we add, the more difficult that is to do that. And this is why right now there is a new field that is it's called X, from the explainable AI, that is trying to understand in more detail what are these hidden layers doing. Yeah, so we know that it works. Yeah, that we can identify a cat or a dog with image recognition, but we don't know exactly what the hidden layers are doing. I'm going to show you some examples of something that they are doing, and it's a field that is very important. Okay, so I just told you that in general we have some understanding of what hidden layers are doing, yeah, but no, we don't have full understanding of what the hidden layers are doing, yeah. So and the exact details can be complex, and sometimes they can be difficult to interpret. And so, for example, this when identifying a picture of a cat or a dog is not like it's okay if we don't understand those details. But for example, if we are looking for bank loans, yeah, if you're asking for a loan and you input all your information and then it get rejected, yeah, we would like to know why these kind of things, why the AI is doing that, and see if maybe it's making a mistake, or is there a particular reason to take that decision. So to understand the hidden layers in some cases will be very important. So so I told you that the neural networks are definitely highly effective, but the decision making process can be sometimes difficult to explain, and this is why there is this leading field that is this X uh, AI, or explainable AI, to try to understand why are the basis of all these decisions and why they're thinking some of those decisions. So now that you know this, that you know that we are not able to completely understand what the hidden layers are doing, and it become more difficult, more abstract, the more hidden layers that we have. I'm going to show you some examples of some of the things that some hidden layers are doing. Okay, so let me show you some examples. Here, I'm just going to tell you more or less what we know that some hidden layers can do, and I'm going to do that in terms of image recognition. Yeah, so the big question that we have is how we go from zeros and one, yeah, what is happening with our input data to be able to say that the output is a dog, yeah, is a cat, is a different figures. And so we don't know exactly what the hidden layers are doing, but as I said before, the more that you know what the hidden layers are doing, the better you can adjust the weights, the better you can make the architecture of the network. So in terms of image recognition, I'm just going to give you very general some of the things that they're doing. So each layer of the neural network is going to transform this input data and progressively move it into complex pattern recognition. So for example, in the beginning, in the early layers, you are going to have basic patterns. Yeah, so these zeros and one will recognize, for example, the edges of this dog. So here you see the dog, and you see that there is a background. So you can see where could be the background, what could be the image that you're going to analyze. Later, in the middle layers of these hidden layers, you can start being able to recognize shapes. Yeah, so for example, this dog have the eyes are more circular, the ears are more triangular, and in that way they can start creating progressively uh, transforming the data to say, like, to recognize this image as a dog, you should have these shapes. And in the deeper layers, the more that are more complex and more abstract, it seems that in some cases you can group those parts of data. Of course, this is a very general, and I'm just giving you more an example of what we know that some of them do. They could be some difference, and somebody can explain in more detail. I will give you some links of what we know. And again, the idea that the simpler the neural network, the easier it is to know what the hidden layers are doing. the more complex, the more abstracts are to do. So what I told you here is that in the context of image recognition, you have the feature extraction and transformation. So you go from zeros and one to edges to shapes, and then to group all together to recognize that these zeros and one that you put in the data, you can transform that data into recognize a pattern. Yeah, transform that into a pattern. Yeah, so going from progressively transform the input data of ones and zeros into higher levels of representation. And to do that, each layer will help us to learn different aspects of the data. And I told you that early layers can detect simple patterns. So for example, it can detect edges, textures in images, and in the middle layers, it can capture more abstract features like shapes and parts of objects. In addition to that, more deeper layers, they do more complex things like grouping. So let me show you an example of that. So here you can see the grouping that I was telling you here, not identifying a, a, a dog or a cat. Here is a giraffe. So you hear that you have here the edge detection that we talk, and all of them work together to at the end recognize the entire pattern. Yeah. So again, each layer will learn something different, and we know that what the early layers and the middle layers in image recognition sometimes can do. Here in deeper layers, as I said, they can combine features to recognize complex features. So I told you about the grouping and how to put all those things together. And so one example of that is full objects in an image that require a high level of representation in text and in an image. Okay, so I know that here I'm not answering all the questions. What I wanted to give you is a very general idea. There are people that with each particular example, so for example, recognize the numbers, they can see, recognize curve. If you're with specific image of dogs and cats, you can see that each one of these layers can do something very specific. Okay, so there will be some links that you can see more in detail and more a more mathematical approach. In this course, we're going to give just a very general explanation of this. Okay, so to summarize all the things that I told you the neural networks, yeah, in the hidden layers, although we don't know exactly what they are doing, the simpler the neural network, the closer that we can understand what some of those hidden layers are doing. So for example, for image recognition, there's an example here of this article that you can find here and this link. Yeah, if you want to read it. And here they're showing an example how to differentiate between a cat and a dog, and there are different attributes, and you can start seeing what the hidden layers are doing. Yeah, and they could be different. Hidden layer can detect things like, for example, that there is color in the center that can help you to detect if there is an eye or not. A curve on the top of yeah, so that it can show you or the eye or the head or things like that. And when you put all those things together in a more complex, in a middle layer or in a deeper layer, you can turn that into structures like eyes, ears, and fur. Okay, so as you see, the more the hidden layers, we don't know exactly what they are doing, but this is why we need so much math, because we need to do a lot of calculation to put everything together, and we need to, if you watch some of the videos or somebody that is working with neural network, you see that they have to, there is a lot of trial and error, and this is why you have to train it so much, because you in the beginning you don't know exactly what they are doing, but the algorithms start learning. Okay, and to finish the section of the hidden layers, the reason why the neural networks work, even we don't know what a hidden layer is completely doing, and in some cases, the more abstract, the more deep learning, yeah, we have, the more difficult it is because there is a lot of math behind. And if you remember, in the beginning, we talk about polynomial equations. We talk about a lot of this, about energy function, and that you can represent anything like a polynomial equation. So what we are doing is actually to some degree, creating polynomial equation with all these neural networks. Yeah, so there is a lot of math behind, and as we train so much, yeah, we give them so much data, and the computer, there is so much computer power that are able to do all these things. So we can go from a simple perceptron that is able to detect a geometrical shape, and we added hundreds and hundreds of neurons, yeah, sometimes millions, and we can detect something much more complex like the image of a cat. Okay, so from something simple that we add a lot of math, then when we exponentially do that, we can go and do something that looks like magic. Okay, so remember, hidden layers we don't know, but there is a lot of math behind that. It support all the findings that we have. Okay, so after all this work, so we finally have our last layer, that is the output layer, where we combine all mathematically all these hidden layers to probability. Yeah, depending on your hidden layer, you can say this is a dog or it's not a dog. Remember, we start inputting our data here, then we transform this data, start finding edges, start finding shapes, and then we group all that data. Depending on how many hidden layers we have, we can do more things, and later all that arrange into that. And depending on the architecture of your network, you can have, is this a dog or not a dog, and you can have a probability. You can set it up from 0 to 50 is not a dog, from 50 to 100 is a dog. Yeah, so depending on the architecture, or you can have like three options. Yeah, from 0 to 25 is pasta, from 25 to 75 is a cat, and the rest higher than that, it will be a dog. Yeah, so all this will turn into again more math. And so what I just told you is the last um, layer of this basic neural network, that it will be the output layer. Yeah, and I told you the output layers mathematically combine the answer to the problem. And here there's an example. I told you, is this a picture of a dog or is not a dog? And here in this case we will have thousands of pictures, and we don't want to do it one by one. We want that the software give us the answer, so we want to label it, and we want to know if it's a dog or not a dog. So in the output layer, yeah, it will that neuron, it will give us the answer, and it will tell us if the image is a dog or not. Okay, and this is the function of this red neuron that you see here. There's the output neuron. Just to uh, tell you a little bit more about these outputs, I just give you another example of a different neural network with a different architecture. In this output, you can have three different outputs. Yeah, so in the previous one, I told you that there were probabilities. Here, it has a different architecture, so you will have different outputs, and to pick these three type of images, and you can have, depending on the network, you can have many outputs. Yeah, but the idea is the same one. Yeah, so if you have many answers, instead of having a single output for labeling, you can have many outputs, but it's the same idea, that each one will give you a probability that the answer is correct or not. And here I just give you some examples. So here it will give you from here to here, from 0 to 20. That will give you, I don't know, 100% chances that you will get a dog. If you have between 25 to 50, that number will give you a probability that will be a car. So it's exactly the same idea, that you just get probabilities, and based on that you can take a decision. Okay, so again, I am simplifying this a lot. I'm just giving you the basics of these neural networks. In future lectures, we're going to talk more about deep learning, yeah? So what we have been talking is about these amazing neural networks. We talk about AlexNet, how it was a game changer, and it didn't happen a long time ago. It was something that just in few years, everything started changing really fast, yeah? So as you can see here, we start adding more hidden layers, yeah? So this is a simple neural network. And the question is like why we don't start getting more and more and more uh, hidden layers to have better answers. Yeah. So if you see the difference between the simple networks and the deep learning networks is actually pretty similar. Yeah. The difference is this here is the hidden layers. However, as you will notice, every time that you start adding hidden layers, you start adding more and more calculations. And as we said before, you start getting more and more abstract or lack of understanding of what is happening. Yeah. So first thing that you need to be aware of that when you use deep learning is that you will need to have better computer power. Yeah. This is one of the things that you need to have. And we will talk about that later. And at the same time, in the following slides, we'll talk that it's not about always using deep learning, it's about using the tool appropriate for the question that you have. So for example, if I want to go to China, it's very good from Canada to China, I will need to use an airplane to go there. Yeah, I cannot go walking, but however, to go to the store besides my house that is 2 blocks, I don't need an airplane. It will be much easier just going walking or taking even maximum my bike. Yeah, that will be enough. Sometimes simple perceptron, sometimes even a neural network will be more than enough. And for our cases, you will need deep learning. Okay. So what I just told you is that deep learning, the difference between deep learning and a neural network is the amount of hidden layers. The more hidden layers, in some cases, you can have better accuracy for some questions. However, it has some expense, has a cost to have so many hidden layers, and one of them is that you will have to have a fast processors. This is why it's so important that these processors that for AI. This is why so many companies are making so much money because they know that you need to have better processors to do this type of AI, and this one can handle millions of calculation that are very quick. And as a reminder, remember that AlexNet, so that thing that it was uh, more than 10 years ago, the game changer, it was already 60 million neurons. So imagine how many neurons have now the current neural networks or the deep learning that we're using right now. So far, I have been talking about the perceptron, then talking about that you can join multiple perceptrons, yeah, multiple neurons, and having this amazing simple neural network. And then in addition to adding more neurons, you can add also more hidden layers, so you get more neurons, you get more computer power, and in that way you can have very cool answers. And that to some degree is true. And this is why so the idea is like, what about if we spend more money and adding more and more hidden layers? Yeah, but this is not completely that is not completely true. I have been missing one component, and it's something that we still need to work more. That is the architecture of the network. So if you see here below, you can see again also a lot of hidden layers. Yeah. However, the way in which the neurons interact is different, and this is another very important component of these neural networks. Yeah, not only adding a hidden layer is important, also the network architecture is also very important. So people is super excited with all the ideas of deep learning, and we will talk about more in a future class about that. And the idea of adding hidden layers seems to be very efficient and solve many problems that before they seems to be impossible. Uh, but in addition to have more neurons, the idea is to also combine the data into more complex ways. Yeah. So, and this has been able uh, to allow to look more complex components and solve thicker problems. So in the following slides, I'm going to show you how different networks can some examples of some different networks. So here, the key thing that I want that you get from this following slides is that there are different architectures. Yeah. So it's not only about adding neurons, it's about how these neurons interact. So we have been talking about inputs, yeah, that you can see in yellow, but you can see that the more complex the neural network are, you can have different type of input cells. We have been talking about a hidden network and hidden layers, and look, you can also have different type outputs here, yeah, and you can have different ones, and even we haven't talked about recurrent neurons or convolution. Later we'll talk about that. But the idea is that the more neurons, yeah, you can have more different architectures and different approaches to solve different problems. So we start with the perceptron, and here you can see this one that you start having hidden layers, but these two are completely different to this one. Here you start having more recurrent ones, yeah. And here you can have another neural network, and each one has names, different names, and is used for different purposes. And let me show you other example. And here, these are some type of architecture that are more that have more hidden layers. So these one are used for example, this is called deep convolution network. Here you have this deep residual network, so this one are more for deep learning. And you can see that you start having, again, many different architecture with different nodes, and these can be still used to improve the performance of these neural networks. Okay, to summarize some of the ideas that we talked today, here you can see in this table, in this column, we're talking about neural network, and here they're talking about deep learning. Here is the definition. Here they show you that there are different architectures, as I show you here, and they talk about the power. So the deep learning can be more efficient, but it will need to have more computer power, and it will take more time for training, but it will have a higher performance. Okay. And now in the next section, we will talk about some of the applications that this neural network can have, as well as some of the uh, problems and challenges that they have. So far, we have talked about that having more layers, all these green neurons seems to be super important. However, as we get more layers, we will need more computer power. And in one class, we will talk about the impact on the environment of doing that. And I'm sure you have heard that, for example, we will need more electricity, and we will need water to cool down that equipment that in some cases there's not a lot of fresh water, so using it for that is has some ethical questions, and maybe when you're watching this video those kind of problems have been solved, but right now those are big questions. However, we are not going to focus today on that. There will be an entire class to talk about that. Today we will talk about the problems about not being able to understand what the AI is doing in some type of on some question. So adding more hidden layers is great, but you will need more math, and you will need faster computers, and this will make more difficult to understand the answers of the networks. Yeah. So I show you that even with simple networks, you kind of guess what is happening, but you don't understand completely. However, when you start getting deeper layers, things start getting more difficult to understand. Okay, so to summarize, I told you again, simple neural networks, much easier to understand what is doing the network. Not always we can get everything, but the deeper the layer, the more abstract and more difficult for human to understand what is happening with the data. And this can become a problem with many cases. And for example, with a bank loan, why a bank give you this wonderful bank approval? to buy your house, but another person you don't get it, this can be a problem. And before you can say, okay, it was because of discrimination. Now people can say because the AI told me that you cannot get that. And again, remember, AI is programmed by humans, so the what it was hidden by discrimination in the past, now it can be hidden in an AI that somebody programmed to not give to do the same thing that happened in the past related to discrimination now, just in terms of AI. And not only with bank loans, I'm sure that you have seen many YouTube videos or in Instagram about people that problems in the States about medications, yeah, so that the insurance don't want to approve the medications or the treatment. And now same thing is happening with the AI, and so they said, oh, our AI said that your medication is not approved, it's not covered. And before you said like why, now they said because AI told us no. So again, it's not that the AI is saying no, is that to some degree we are programmed the AI to say no. Yeah, so so it's very, we need to understand very well in some cases what is happening. So in this case, if the neural network is say yes or no, it's very important to know why. And with the medication, it's even more important. And so we need to make sure what features make the difference, yeah, and how the weights are organized, how the network is organized for the final answer. And even in some countries, uh, and we have the legal right to understand why those decisions are made. Yeah, so this is, in other words, AI is a wonderful tool, but you can still use it to manipulate people, and people with power will can take advantage of this. So the more that we understand it, the better that we can fight those things. And there are hundreds and hundreds of applications on neural networks. So from banking to social media. So we talk about loans, but fraud detection, as usually, there are many examples of from unsupervised learning to neural network to deep learning to detect fraud in banking. In healthcare, it's very common to use now cancer screen, and in those cancer screens using AI, for example, you have a neural network that is able to see image of a cell and decide uh, if there is a risk or no, and it's becoming very common to that. And we will talk about that later. Some of those applications. I'm sure that you have used Alexa and Siri, and although at this point there is still problems, they have improved considerably from the past, and I'm sure that they will continue doing it. And as we talked in the beginning of the class, every time that you tag a picture, yeah, in social media, this is done by neural networks. So neural networks are already everywhere, and deep learning also is everywhere. And this is why it's so important that we understand it so well. And I gave you an example why it's important that if we understand it very well, we can have improve the impact in our society, and instead of having bad effect on our society. So to summarize this section, I told you that there are some challenges and ethical concerns about AI and neural networks, and this is because there is a black box, and sometimes we cannot explain the decisions that the AI is doing. So there is a field that is trying to understand in more detail why AI is taking sometimes those decisions, and this could have some legal implications. So for example, I cover bank loans, but for example, same thing can be happening with hiring. I told you about covers for medical treatments or medications. They can be some examples of why it's so important to understand AI and why they could have some legal implications. And the idea is that in the long term, we need to, the more that we understand AI, the more that we understand neural networks and deep learning, we can have some transparency and fairness for AI. And in a future lecture, we will talk about the biases that can be the bias of the AIs and how we can reduce them. But there is something that definitely, the more that we study, the more that we understand it, even the general public, we can all work together so we have a better society. Okay, so again, I hope that you enjoyed this small lecture. If you have any questions, let me know. I know that it was very general, but over in the following lectures, we are going to cover and go more in detail about some of those aspects. Have a good day and bye.